Now about the hashCode method. Okay, so one requirement about the hashCode, right? For any object O, okay, so let me first put some requirement which are expected. Okay, this is with respect to the equals method. Okay. So the requirement is if two objects are equal according to the equals method. If two objects, let me say A and B, non-null objects, yeah. A and B are equals according to the equals method, okay, then what is expected here is A dot hashCode will be same as B dot hashCode. It is expected if they are equal, their hashCode will be equal. Okay, and this is the expectation. Okay, and so if two objects are equal, their hashCode also should turn out to be equal. So it's because of this rule, okay, because of this kind of an expectation, okay, whenever we override right, so it almost becomes a rule like this. Whenever we override equals, we also override the hashCode method. Fine, clear on this? Okay, fine. See, because equals is using some attributes for making comparison. The idea is hashCode has to be computed based on that only. Okay, hashCode should be computed based on the same attributes which are used in the equals method. For rectangle class, equals method uses length and width, and therefore the hashCode method must be based on length and width. You can put anything, okay, and it's your method, but yes, take care of this. Okay, fine, clear? Fine. So these are expectations about whenever we override these kind of methods, equals method and the hashCode method. Okay, especially the equals method, you are overriding equals, okay, fine, that is overridden so that we can have our own way of defining the equality. Okay, right. And when you override for equality, yes, hashCode also should be taken care of. Okay, because hashCode is a value which is used by some of the data structures. Okay, so we have data structures like a hash table. Okay, and in case of Java, we have some kind. Later, you will come across the API where we have something called a map. Okay, map is nothing but a hash table implementation. Okay. So in such cases, yes, the hashCode is used for the keys and to decide where it goes. So computing, it depends on hash. So you don't compute the hash. You call the hashCode method on an object to know the hash value. Okay. Okay, so hashCode has to be a computed value. Okay, so fine, let's override the hashCode now. So this is which class? Yeah, this is in the rectangle class. Okay, so public boolean, not boolean, it's int, right? Hashcode. Yeah, so what should be the hashcode? Something based on length and width, because equals method for rectangle is based on length and width. So this should be based on the length and width. And therefore here we can say return, okay, so length plus width or something like that could have been done, but let's also use something more. We can, don't forget that we have these classes called the wrapper classes are available, right? And they hold the value of the primitive type. And therefore, if you want, we can do something like this. Let's cast into integer. Okay, cast into integer what? This dot length. Okay. Right. So if I cast it into an integer, this whole thing is cast into an integer. Okay, because the type is int, right? Primitive, so I'm making it as wrapper. I can use a hashCode method. Okay, plus, and same way I can use hashCode on width. I'm just adding them in a simple thing. Okay, so that's also fine. You could have written any kind of formula based on length and width. Okay, fine. A very common thing. Okay, this is one I have written. A very common thing could have been something like this. Someone could have said, okay, length plus width. Okay, and this whole thing, okay, modulus and something like this, some prime numbers. Normally we do something on these lines. Okay, right? Get a prime number and take a modulus with that. Okay, so this kind of thing is more common. Okay, fine. But anyway, we can have the other one. Okay, fine. We may keep it something like this also. Fine. This anyway is also fine. Okay, it has to be a value which depends on the same attributes as equals method. Equals depends on the length and width, so my hash code should depend on length and width. And so yeah, overriding hash code for cuboid then. Okay, overriding hash code for the cuboid. And how do we do this? Yes, you want to use a super hash code. Okay, you want, yes, you can say return super dot hash code plus cast into integer. Okay, this dot height, and maybe something like this. Okay. So the effect of overriding hash code, you may not see it here. Okay, but if you don't make this kind of, the expectation which I put in the hash code method, fine, for the consistency which it should have with the equals, that is, the requirement is, if we consider A and B to be two objects, if they are equal, and their hash code should match. And if it didn't match, okay, if they didn't match, fine, then you will have problems. You will find unexpected things happening when we involve these kind of objects in our hash table. When we use it with a map as a key, if it is used as a key in a map, fine, then this is going to give us problems. Your map behavior will not be consistent. And the reason why we should be overriding the hash code. Okay, so we have fine. So normally these are the three methods we would be overriding.